Okay, so in the last session we have completed this exercise. Now the next exercise is what? We have to model this truss, and then we have to find the internal forces in the member of truss, and this will be what? These all are the values of the forces, and these are the respective natures of the forces for the in a particular member. Got it? So I hope you all can do this exercise on your own. So I'm not going to take this one. Now come to second one, like third one. Here we have to find the again. We have to do the same again thing. Again we have to do the same thing. Got it? We have to find the member forces. Then we had to check it with your manual calculation along with the nature, and we have to check whether the values are matching or not. So just tell me, will you do this on your own? Can I left it?
इसमें जो 30 किलो न्यूटन का लोड है उसको कैसे लगाएंगे?
दिखा दीजिए एक बार.
At least you should try. Okay, you should try. I'm not going to take this. You have to do this. Okay. And when you are going to practice it, so some problem you will face, and that if you are facing some problem, and then let me know what kind of problem you are facing. Then I will guide you how you can correct that. Got it? Hello.
Yes, sir.
Okay. So try this on your own, and let's check. Let's validate it with your manual calculation. And this one is the complicated one. So I am going to show this one here. Okay. So just tell me, how many grids are there? Will be there in plan?
5.
This is the first. This will be the second. 5. It will be third, fourth, and fifth. These 5 grids. 5 grids will be there in X direction. And how many grids will be there in Y direction? Can anyone fast?
1.
4.
1.
Sanjay?
1.
Yeah, obviously it will be 1. So just go back to your ETABS and just go to new model and let me know what unit system we have to take. Either US default. Sorry?
Yes, metric SI.
Okay. So let's go with this third option. Metric SI will be there. Indian code will be there. And design steel code will be IS 800 2007. Concrete design code will be IS456 2000. With all of these basic definitions, just click simply click over this OK. And thereafter, we have to define in plan definition. We have to set here for the grid. So 5 number of grids will be there in X direction. In Y direction, there will be what? Actually, one grid will be. And let me know, it is of uniform spacing or non-uniform spacing?
None.
Uniform.
Exactly.
Non-uniform.
It is basically non-uniform spacing, and but we can take the help of uniform because 5 meter is going to be repeated 3 times. So this kind of spacing we are calling it as what? Typical spacings. Got it?
Yes,
hello.
sir.
And
Yes,
over height, if you are saying, so we are going to call it as typical height, means the height which is going to be which is repetitive. So we are going to call it as typical height. And if the distances are repetitive, then we are going to call it typical spacing. So here typical spacing is what? 5 meter, 5 meter, 5 meter. So we are going to take the help of this spacing of grids in X direction as 5 meter, spacing of grids along the Y direction. So in the last session I told you like 0 value you can't put here. So at least you have to start from 1. So put it as 1. Okay, just let me know. It is needed to go with the custom fast.
Yes.
Yes.
Yes, sir.
Very good. So we need to go with the custom. Go to custom. Go to edit grid data as spacing. Sorry, this option. Then we need to go with the second option, edit grid data as spacing. Check this option, and then A to B is 5, B to C in reference of B is 5, C to D in reference of C is 5, D to E in reference of D
6.
is what?
6.
6. That I am going to put here as 6. Last will always be 0 if you are working with this second option. Remember, okay? Next, along the Y, no need to worry about. Let it to be as it is. Now, here, bubble sizes, okay, it is not overlapping in this quick window. You can see how your grid will be in plan. Okay, So I will have to take the color as some dark color value. I'm going to take, let's say simply okay. Let's say simply okay. Once you click over the okay, now very interesting, and you all have to answer to this question. How many levels will be there? First,
4. 3 level plus
four.
base 4.
3.
Okay, 3. Some of you are saying that it is 3.
Three.
Some of you are saying that it is 4. Okay,
3.
including base. Let me know, including base. Then
4.
4.
4.
okay, so all those who are saying that 3, they are saying that now 4. So 4 is actually correct. Okay, because you are saying that without of considering this base, I think you are saying 3, right?
Yes.
Yeah, so including this base, it is 4. If you are excluding this, if you are not considering this, then it will be 3. Both are correct. So it will be your base, it will be your first level, it will be your second level, it will be your third level. So first, second and third, these 3 levels will be there. Got it. Now the another question is what we need to know, what is the height of these levels. That is important, because it is our base. So let's say it is at 0. So from this 0 level, what is the height of G, what is the height of this F in reference of G or in reference of base, and then what is the height of A in reference of F or in reference of base, that we need to know. So how we can do that? Very simple. That is what, very simple. Trigonometry we are going to use. Okay, it is what, triangle is there, and we know this height, we know this base. We can calculate how much this angle, alpha or theta, whatever you would like to call. So let's say how much alpha or theta will be. That will be what, tan theta or tan alpha, that will equal to height upon base. Your height is 8 meter and your base is how much?
15.
15. So it will be what, 15. Then it will become alpha is equal to tan inverse of your 8 by 15. Let me know the answer.
28.07.
18.07 degree is your,
27. 28.
sorry,
28. 28.
28 it is. Okay,
28.07.
28.07 degree it is. So I'm going to put it here as 28.07. Now the angle we are knowing, that is what, 28.07. Okay, now after getting this angle, it is very easy to know how much height it will be. Okay, so height is very simple, angle we are knowing. Okay, so tan theta or tan alpha is equal to height, that is unknown, we need to know, upon base is what,
5.
5. So it will be what, 5. So take it 5 on that side, h equal to 5 into tan of 28.07. Now let me know what is the answer fast.
2.667.
2.663.
63. Okay, up to 4 digits you are saying that. So okay, 2.6663. Now second time, this height I need to know, this height from this base. So that is going to become what, 5 plus 5, 10. So 10 times 10, 28.07.
5.3327.
7. Now tell me the answer.
5.33.
5.3327.
5.3327.
3327. 27.
Okay, now next, third time we need to know this height, but it is not needed to calculate, it is already 8. So it will become what, 8 meter is your final height from base to this level. From this level to this, it is 8. So this is what, in reverse way we have to calculate. What is the difference between this? So 5.3327 minus 2.663. What is the difference between these two? What is the difference between these two? Hello.
ये आएगा सर 2.6663.
यही आएगा exactly 2.6663 it is now. Then last 8 minus 5.3327. 8 minus 5.3327. What you are getting between these two difference? Tell me.
2.66.
Again
667.
2.6663. Am I right?
Yes sir.
So basically each level height is what? 2.6637. And if you are going to take this 2.6637 three times, you will get this value 8 meter. Okay, we will check it. So excluding the base of this model or this structure, there is actually what? 1 2 3 levels. Just go back to your ETABS and put it here as what? 3 levels. Number of stories excluding base is 3. Typical story height is what?
2.66.
Okay, 2.6667.
Yes.
And bottom story height is again it will be same, 2.6667. Okay, need to go with the custom. Just click over this custom, go to edit story and grid system. Once you click over this, okay, now here it is a base at 0 level. From base to first level, you can write here as first level. It is what your
है 2.6663.
it is what your second level. It is what your second level, and this is actually what your third level. Third level. Whatever the title of this story you would like to give, you can put here as per your choice. Now these are the what respective height of that particular floor below the lower one. So from first to second is 2.67, from base to first 2.667, and from second to third, or means your third is at a height of 2.6667 above your second, and total cumulative height is going to become what? 8.00001. Got it? So it is what? Totally 8 meter. Is that all okay?
Okay.
Okay, what other things is there? You don't need to worry about. Okay, don't bother about these all things. Let it to be as it is. Let's say simply okay, this is all done, and we need to have the grid. Just go to this grid system, grids only, check this option. Let's say simply okay, and once you click over this, so these grids will be there. And as you know that it is what? The elevation view. Okay, as it is the elevation view, okay, so along the grid first we need to see the elevation. Okay, just close this 3D view. Now close this. Now go to elevation, and along the grid first, let's say simply apply. So now we are having what? Elevation view. The base is there, first level is there, second and third. These all 3 levels are there, and now we have to start the modeling. Okay, so see, just go to this frame, and now close it. This dialog box. How you can start the modeling? You need to click over this frame. Once you click over this frame, and this dialog box will open, and now close this dialog box, and see, our first point is what? At the intersection of this it is what? It is the grid 1. Along the grid 1 we are looking for the elevation, and at the intersection of D. So from here your modeling is going to be start. This will be the base point. Then click on this first point. Now from this point to this E, there is a single element. There is what? Single element. So from here to here, one single element is there. Now I can use the continuity of this command, because there is what? Another member is E to D, D to C, C to B, and B to A. So continuity of the member is there. So some of you may think that I will take the point from here to here directly, but it will be wrong. It will be what? Wrong. It is going to become what? Single element, single member. So that is not accepted. As in the last session we have seen that what assumptions in the for the analyzing the truss element or truss structure. So each member will be what? Separate. Their connection, their end-to-end connection will be there. So at every point you need to break it. Look at your question. So member is there one, here the member is, here the member is going to be end, here the member is going to be end. So this is the one member, this is the another member, this then is another member, and now this one is the another member. So I will use the continuity. Okay, go to this undeform, undo, come back. Okay, again go to frame. I am going to repeat this step. Go to frame. Now close it. This is the first point. This is the first point. Unless and until you are not getting this sign that grid points D1 base, okay, don't click over that. Once you got it, then click over that. Take your cursor to your required point, then click over that. So the member has been modeled. Now I will take, I can off this command temporarily. Actually I can off the continuity, not the command. I can off the continuity, not the command. Okay, but here there is a use of this continuity. So what I am going to this point, next model, then come to this point, this is done, then come to this point, this is done, then come to this point, this is done. So all these four members, E to D, D to C, C to B, B to A, all these members I have modeled. Okay, next, tell me, along this A to H, there is no single element. There is again A to F, one element is there. From F to G, one element is there, and from G to H, one element is there. So basically what we need to do, we need to okay, I am going to take directly from this point to this point, and later on we will correct it, because we are not sure that this is the point. We are not sure that where is actually this point F, where is actually this point G. We don't know where is actually the point H. H is there, but we don't know about F and G. Right or wrong? Hello.
Yes, sir.
Yeah. So for that, what I am going to do, I am going to take one element from this point to this point directly. So will it be right? Hello.
Yes, sir.
Can I keep this member as a single element, or we need to break it?
Break it.
Yes.
Exactly. But for an instant, I have modeled it as a single element, but it is not right. But for an instant, we have modeled it. Later on, what we have to do with this, we will see. Got it? Now, next, again take the frame. Again go to this frame and close this dialog box and click on this first. Look at your question. Now from B to F, C to G, B to F and C to G. These two, just go back to your ETABS again and just click over this first. Then yeah, now intersecting point we are getting. Okay, now click here. Intersecting of what? Your frame and grid. So then click over that. Grid point and second level point. Intersection we are getting. Then click over that. So one has been modeled. Now from here, then I am going to click here. Okay, so this is now modeled. Now from this point to come to this point and then click here again. So now finally your all the elements has been modeled. Now the continuity is there. To off this continuity, right click on your mouse. So this continuity will be off. Is that all okay or not? Next, you may say that sir, it is very difficult to catch where is actually the member and where is actually the grid, right? It is difficult or not? Hello. So I am going to keep these grids, means the dark color for these grids we have taken. So I am going to make it as light. So go to edit stories and grid system, go to modify and just take the light color of this grid. Let's say simply okay. Let's say simply okay, and let's say okay. So now it will be easy to catch where is your member is available. Again, we have to model this F to C and G to D. Go back and take the frame again. Now close it from this point to this, right click from this point to this, then continuity is there, right click on your mouse. Now all these elements has been modeled for this. Now next, editing work. So this frame we have modeled as a single element, so we have to correct it. So drag it from left to right, so that what I would like to break this member, I would like to break this member at this point, at this point. Okay, so how I can break that? So first select the frame, then drag from left to right. I would like to break this frame at this joint. I would like to break this frame at this joint. So simultaneously at multiple points you can break your element. But to use this command, what you need to do, you need to select the frame and you need to select the joint at which you want to break it. So go to editor and go to edit frames and go to divide frames, and then go to break at intersection with selected frame and joints. Just check this option and let's say simply apply. Once you click over the apply, now close it, check it whether it is divided or not. Say first element, now it is separate. Second element, now it is separate. Third element, now it is separated. Is that all okay?
Okay.
Okay.
Clear?
Clear.
No. Second thing, again you may ask, you may say that these grids are creating the disturbance. Means it is not able to, we are not able to catch these elements. Okay, where the elements are available, we are not able to catch it. So what the option is there, after your modeling has been completed, you can off the grid lines. You can off the grid lines. So right click on your mouse and set grid system visibility. Set grid system visibility. Once you click over this set system grid visibility, these grids will be off and only your elements will be there. Is that all okay?
Okay, sir.
Okay. If you are right click again, you are again on this window. So set grid system visibility will be there. If you are again click over this, so the grid will be available. If you are right click over this, if you are clicking over this set grid system visibility, it will be off. So it's your choice whether you want to keep that grids to be in view or not. You can right click over this and get system visibility. Got it? Now,
Sure.
second, in the last session we have seen that at the base, software will automatically assign the support, and that support will be what your that will be hinge support. At the base of the structure, at the base of this level, software will automatically create the support, and that support will be what? Hinge support. So suppose I am going to take any point, even I am going to draw the point. So go to draw point. See, I am going to click here, simply point I would like to put here. So see, I am going to put here as point. So I am clicking point. So software will automatically assign the support to this point as a hinge support. See, is that all okay? Hello.
Yes, sir.
So I have not assigned any
Yes, sir.
support condition to this joint, this point, but software is doing by default. So undo this. So that you need to remember. Now drag it from left to right. Let this joint to be selected. Okay. Come to your question and let's see, check. So at this base H, what support is there? It is what?
Roller.
Roller support it is. Yes, it is roller support. So drag it from left to right. How to make this, how to do the selection of anything, that also we have covered in the last session. So drag it from left to right, let the joint to be selected, then go to assign, go to joint, go to restraints, and for the roller support, let's say simply apply. Once you click over the apply, so this hinge support is going to be converted into what? Roller support. Very simple. Now at this, there is what? Don't think it is horizontal, vertical. That is not making any means. Let it to be. So it is what? Like hinge support. It is not roller. It is not fixed. It is basically what? Hinge support. So go back and drag it from left to right. and now simply assign the hinge support. See, second option I'm going to take. I'm going to take this second option, hinge support. Let's say simply apply. Once you click over the apply, so the hinge support has been assigned to this. Now your all the elements has been modeled, all the support condition has been assigned. Next part is what we had to assign the loading. We had to assign what? Loading. So basically here is 24 Newton, here it is 40 Newton. 24 Newton, it is what? 40 Newton. So this will, if I am going to calculate in kilonewton, how much it will become? So 24 divided by 1000 will give you what? The value in kilonewton, right? So if you are going to calculate, so it will become 0.24.
0.02.
Point not 24, I think, right? Hello.
No,
Right.
0.04.
0.024.
Yes, yes, yes.
Right.
I was wrong. So see,
Point
point not
one, two,
point
three.
not 24. Okay, so this will be in kilonewton. Likewise, for 40 it is going to become 0.04. Okay, so just go back to your ETABS. And why we are making this conversion? Because software is asking to put the value in kilonewton, not in newton. Okay, so like here we have to assign the load, so drag it from left to right, let the joint to be selected. So yeah, joint is only one, but those who are practicing with this ETABS software first time, those who are learning this ETABS software first time, those who are going to practice this kind of example first time, take care for modeling of this truss, and cross check will be there. See whether your modeling is right or wrong. See, drag it from left to right, and how many joints should be in selection? One. So yeah, here one joint is selected. That is our intention, because all the member should come at one point. All the members should come at one point. So obviously one joint will be created here. But some of you, when you are with some of you, the problem may arise that when you are going to make the selection and dragging from left to right, so instead of one joint you are getting the selection of three joint. Hello.
Got it.
Yes, sir.
So means what? There will be what? Modeling error. While making the selection or clicking over the point, you are doing the mistake. That's why you will get the number of joint. So that's why I'm saying that very carefully you have to click over any point. You have to take care while modeling, while making the clicking over any point. Got it? Unless and until you are not getting the sign and red point, okay, don't click over that. Right, so my modeling is correct. See, I'm dragging from left to right, so how many joints I'm getting? Yeah, one joint. It means my model is correct. The at this point, every joint every ends of every elements are connected actually at one point. Then go to assign, go to joint load, go to forces, and under the live load pattern I would like to assign the load. So change it from dead to live. By default it will always be dead, so we have to change it to live. Go to live, and in global z direction means vertically downward, how much we have to put here?
Minus 0.024.
Very good. In gravitational direction downward, so minus 0.024. Here it is asking kilonewton, that's why we need to put it as kilonewton. Don't need to worry about any other things. In the last session I have explained in detail about the meaning of all these three options, so I'm not going to repeat those all things. Now simply say apply. Once you click over the apply, so the load is now assigned here. Actually software is showing the value up to the second digits only, up to 2 decimals only. Okay, if you are going to see the result up to third decimal, so how much it will be? 0.02. Okay, some of you may say that sir, I want to see the values in up to third decimal. Then what? So very simple. Go to option, and go to display units, and look at the forces. Places for decimal, it is what? 4 already has given. Why it is not showing? Actually, from here you can change up to what decimal you want to see the result. But yeah, it is already okay. Let it to be 3. Why it is not showing? Okay, but the value is correct. Has been assigned as 0.024. I will let you know. Okay. Hello.
Yes, sir.
Okay.
Yes,
Now
sir.
drag it from left to right. Drag it from left to right. Let this joint to be selected. Let this joint to be selected. Then go to assign. Go to joint load. Go to restrain. Sorry. Go to joint load. Go to forces. Now at this time I would like to assign 0.04
40.
0.04
4.
vertically downward. Let's say simply apply. Once you click over the apply, so that load has been will be assigned to this point. Clear or not?
Clear.
Clear, sir.
Very simple, very simple. Got it? So this is all done. I don't want to see these grids. Right click, grid system visibility. This is all done. Once the modeling gets completed, all the assignments has been corrected for the support, and then all the assignments for the loading has been done. Next step is what? Check for the model, whether your model is right or wrong. So how you can check that? Go to analyze, go to check model. Once you click over the check model, select all of these options. Along with this option, let's say simply OK, and let the software to take some time to show the result. So what? Model has been checked, no warning messages are there. Now close it. Then you are allowed to perform the analysis. Now go to analyze, and in analyze the option is available, run analysis. Then click over that. So your analysis will begins, and it is asking to save your model. So I'm going to save it. I'm going to save this in this anywhere in delete folder. I would like to save it. Okay, 0001. Save this model. Now it will show you analysis result. Okay, what analysis you are getting? Analysis result you are getting. See. Hello. Then now start the animation. Why we are going to perform the start animation? Let's see. It will means by performing the by just seeing the animated shape of your structure, animated shape of deformed structure. You can see that whether the joints are properly connected or not. Whether the joints are properly connected or not, that you can see. If any joint is by mistake, if suppose not properly connected, if suppose it is not properly connected, so by seeing this animation you can catch that. But here your entire structure is what behave as a unit element, as a single element, single structure. There's no any discontinuity between the members. All the members are properly connected with each other. Okay, sometimes what happen, I will take this point in detail in our real life project. That what see, sometimes your software is lagging to catch the modeling error. As I told you, those who have attended our demo session, there also I have taken that this point, that what software is lagging to catch your error sometime. Means what? Your software show that go to analyze. Okay, unlock your model. Go to analyze. Go to check model. Making this all of this selection, and let's say simply okay. So what your software is saying here? Hello, model has been checked. No warning messages are there. Means your model is perfectly correct. Hello.
Yes, sir.
There is
Yes,
no
sir.
any
Yes, sir.
modeling error. There is actually no any modeling error. What is said? Who said this? Your software is saying that there is no modeling error. But sometimes what happen? Software is doing the mistake to catch the error. It is showing what no error is there. But in actual, if you are going to see, in actual, if in deep, if you are going to check, so the errors are there. Errors are normally present, and software is showing what no error is there. So how to like catch that kind of problem? There are different ways, there are different options. Amongst all those options that I will share, every option I will take timely, but out of all those options, one option is what? To check your animated shape of structure after the performing the analysis. Getting or not? So see,
Yes,
start
sir.
animation. So here what? Every points are connected properly to each other. Okay, so this is all done. Then I would like to see the reaction. So go to display and go to force stress diagram, and here the option is what? Support and spring reaction. Click over this, and here it will be what? I would like to see the result. Okay, this go to live, go to this live, and this above upward direction, check this option. Let's say simply apply. Once you click over the apply, so it will show the reaction. So how much reaction is there? So let's see. So yeah, reaction is not given to check. Okay, reaction is not shown here. So okay, left it. We have to focus only what? Member forces. Okay, so just go to see the member forces, go to display, go to go to display, go to force stress diagram. I would like to see the member forces. Click over this, and under the live load, load case as live, I want to see the axial force, and rest of all things will be as it is. And check this option also. I would like to see the values of the forces also. Let's say simply apply, close it. Now here between a to between A to B, A to B, B to C, C to D, and D to E, same loading is there is what? 30 Newton. In kilonewton, how much it will become?
0.03.
Point not 3.
Zero.
Yes,
0.03.
point not 3 kilonewton. Let me check it with software whether it is right or wrong. 0.027, 0.028, 0.03, 0.03 here you are getting. So here you are getting what? Wrong value. Hello.
Yes, sir.
Right. Okay. Now between these A to F, F to G, G to H. A to F, it is 0.031, 0.034, 0.034. So what is there actually? A to F, F to G, and G to H, 34. So basically here 0.034, 0.034 it is right, but here you are getting the result as wrong, 0.031. It is wrong value you are getting. Okay. So on in this long span element, here it is what? E to H. E to H is what? 50. And what you are getting in your result? 0.049. So and in this vertical element, D to H for 24. D to H, how much it is? 0.024. So almost results are very close but not exact. Hello.
Yes, sir.
Yes, sir.
Somewhere it is what? Lagging from of your actual result. There is a difference in your result in comparison of your manual approach. So now tell me how you can correct it. What problem
We have to
what
release,
important step we missed to correct?
we have to release
Hinge
the
member.
Sorry.
Provide end hinges for the members.
Exactly. We have to assign the hinges
we
to
have to
all the members.
Joints are pinned.
Yeah, joint should
release
be
the
what? Pinned connection. That's why what? We need to assign the releases. Clear? So for that, we need to unlock our model. Unlock your model. Once you click over the unlock, then make the selection of all the frames. Drag it from right to left in such a way that your box should cut the element. Okay, how many? 13 number of frames are there. Then go to assign, go to frame, and go to releases and partial fixity. Click over that, and on left hand side and on right hand side, both of the end we have to assign the support. Let's say simply apply. Once you click over the apply, let's say simply okay. See, The hinges has been assigned. Perform the analysis and let the analysis to be completed. Okay, now close it. And now at the again I would like to see the result. Go to display, go to force stress diagram, frame and pier spindles, and axial forces, and rest of all things we have to keep as it is. Let's say simply apply, say okay. Now see, 0.034, 0.034, 0.034. Second one, F A F F G G H, 0.034. A B B C C D D E, it is what? 0.03, 0.03, 0.03, 0.03. Also just see, your nature of force is what? Tensile. Here nature of force is what? Tensile. So look at your manual approach also. Here it is what? Tensile. Rest of all are what? Compressive. So go back, it is what? Compressive. And very exact result the software is giving. Here the values are what?
Not zero.
No value, no stress diagram you are getting. Means actual force in this is what? 0. And your software is saying what? 0. In your BF and CF, CG and GD, here all values are 0, and your software is also giving the same result. Is that all clear? Hello?
Clear.
Yes, sir.
Okay. So in this way we have to validate the result of the software with your manual approach. Okay, is there any question about this?
रिलीज कैसे किया?
अच्छा, रिलीज कैसे करना है? ओके, गो बैक टू योर ETABS, unlock your model. Okay, for assigning the release you have to unlock your model. Once you unlock your model, all the results will be deleted. आपको रिलीज असाइन करने के लिए अनिर्बान सर पहले सारे मेंबर्स को सिलेक्ट करना है. रिलीज असाइन होता है मेंबर को. ओके, सो मैं सारे मेंबर्स को सिलेक्ट करता हूं इस तरीके से. आप ऐसे भी कर सकते हो या मेंबर के ऊपर क्लिक भी कर सकते हो, आपका चॉइस है. मैं इसे सिलेक्ट करता हूं सारे मेंबर्स को. लेकिन मेंबर सिलेक्ट करने के बाद आपको ध्यान देना है कि 13 नंबर मींस फ्रेम सिलेक्शन शुड बी देयर ओनली. 13 फ्रेम सिलेक्ट हो गए. देन गो टू असाइन, गो टू फ्रेम, गो टू रिलीजेस एंड पार्शियल फिक्सिटी. यहाँ पर क्लिक करने के बाद लेफ्ट चेक करना है, राइट चेक करना है, सिंपली अप्लाई कर देना है. लेट्स से सिंपली ओके. समझ में आ गया?
हाँ.
अच्छा, इस तरीके से हम लोग रिलीज असाइन करते हैं. अच्छा, और कोई प्रॉब्लम किसी का?
Sir, how can I erase a line? Say I have drawn a line in a wrong joint. So, how to erase that?
अच्छा, कैसे ज्वाइंट को? अच्छा, लाइन फ्रेम अगर आपने ड्रॉ किया उसको इरेज करना है.
Yes, sir.
सपोज मैंने एक मेंबर सपोज ओके ये पॉइंट से एक पॉइंट लिया मैंने, यहाँ पर ऐसे मॉडल कर दिया. ओके, लेकिन मॉडलिंग होने के बाद मुझको पता चला कि ये एक्चुअली थोड़ा सा पॉइंट नीचे चाहिए था मुझको, 1 मीटर नीचे. यहाँ पर भी मेरा ग्रिड पॉइंट है. सपोज एक ग्रिड यहाँ पर है, एक ग्रिड यहाँ पर है. ओके okay, now select this frame. Now go to editor, go to delete.
Okay.
Then select this frame, then go to simply edit and say delete. It will be deleted. Now again select the frame. Now close it. First point is the second point and this is the third point. Is that all okay?
Yes, sir.
Undo this and just undo this. Now clear this all. Okay, in this way you can multiple times you can draw, you can delete your choice. Okay,
Sir, joint को भी मतलब जो सपोर्ट होता है उसको भी सेम तरीके से डिलीट कर सकते हैं?
यस
मतलब
वो भी कर सकते हो आप. अनलॉक करिए, पहले ड्रैग करिए फ्रॉम लेफ्ट टू राइट, लेट द ज्वाइंट टू बी सिलेक्टेड. यहाँ पे असाइन में जाइए, ज्वाइंट में जाइए, रिस्ट्रेन में जाइए और इसको नन कर दीजिए. अप्लाई, रिमूव हो गया. मुझको यहाँ पर लगाना है फिक्स सपोर्ट, तो मैं फिक्स करूंगा, फिक्स चेक करूंगा, अप्लाई. मैंने आपको कहा है कि बार बार आपको अप्लाई पे करना है अगर आपको विंडो मल्टीपल टाइम यूज करना है तो. समझ में आ रहा है? हेलो,
ओके सर.
या ड्रैग
Yes,
फ्रॉम
sir.
लेफ्ट टू राइट. आपने रोलर तो देखा, आपने फिक्स तो हिंज तो देखा. फिक्स सपोर्ट कैसा होता है? इस तरीके से होता है. हिंज सपोर्ट कैसा होता है, इस तरीके से ट्राइपॉड टाइप. एंड रोलर कैसा होता है, ये लाइक सर्कल, ये आपका ज्वाइंट सिलेक्ट करिए फिर असाइनमेंट करिए, रोलर अप्लाई, तो ये रोलर हो जाता है. सो मल्टीपल टाइम्स और नन भी कर सकते हो आप, नन अप्लाई, अगेन सिलेक्ट, देन असाइन, गो टू रोलर से अप्लाई, इट इज डन. एनी अनदर क्वेश्चन फास्ट. So this is all about today, and we will start a important point. Tomorrow we will take one of the another important point, that is the part of this validation exercise. Okay, that is for the beams. So don't miss tomorrow's session, and do the practice with all the things that we have covered, and practice to complete this exercise, this example, and let's check whether you are getting the right result or not. Okay.